Okay, hopefully you can hear me. Welcome back, everybody. Well, tonight we've got our guest speaker, Andy Tilson. He's Managing Director of Meridian Generic Rail, and he's going to talk us through rolling stock and the road to delivery. So if we could all welcome Andy with a round of applause, please.
Thank you very much. So good evening, ladies and gentlemen, people in the room, people online, members and not members. So forgive me, it's been a while since I've done this, so I'll probably be referring to my notes quite a bit, but hopefully you enjoy what I have to tell you. And thank you to the IMechE for inviting an IET member to give a speech. So by way of introduction, my name's Andrew Tilson. I'm the Managing Director of a company called Meridian Generic Rail, and we are a rolling stock engineering-based company which I formed in 2007. I'm a dual-trained electromechanical engineer, and I've spent the last 21 years in the rail industry. I have held some fairly prominent positions in the industry myself, including being a commissioning engineer for Bombardier for the Electrostar fleet. I was a technical engineer on depot for the Virgin Pendolino fleet, and I was also the fleet health and reliability manager for Northern Line at Golders Green many years ago. So here we go for people online. There's some bullet points. And my company, which I wanted to give you a bit of background on too, so you know who is actually speaking to you. I originally formed the company back in 2007, as I stated, and it was formed to engage with Porterbrook Leasing to take the 458 fleet out of mothball status. We would undertake all of the regular maintenance, the warranty, defect maintenance, and the main goal was to improve its reliability. We did so successfully, and in fact, anybody who remembers the fleet in the early 2000s would know it was on the cover of a well-known publication called Railway Blunders. In fact, we're instrumental in taking the fleet, which was the worst performing in the UK at the time, doing circa 2,000 miles between failures, to in excess of over 76,000 in a period of 9 months. Thus, it became the best performing EMU fleet in the country and was like that for several years. We were later involved in the introduction of new technologies into the rail industry, mainly driver advisor systems and energy metering, and it was actually my own primary design that was implemented as a combined DAS and energy metering system. It was the first to be retrofitted in Europe, and it was performed on the Class 334s in Scotland. A bit later on, in 2015, we specialised more in testing and the introduction of new fleets. And 2015 saw me spend nearly a year in Brazil type testing with the introduction of new trains for the 2016 Rio Olympics. Later, we were also involved with some of the Hitachi fleets as well. But since 2017, we decided to go out and purchase our own test time at European test centres. And we offered turnkey solutions for Bombardier, Alstom, and the Chinese CRRC, just to name a few. So today, what I'm going to talk to you about in brief is the process of rolling stock from design, conception to network approval. And not to make this too much of a lecture, I will be focusing more on some of the challenges our own company have experienced and undertaking parts of this process. So while we're here, and probably why should you listen to me? Because I'm sure there's a lot of very qualified and experienced rolling stock engineers out there. And I have detailed this more for perhaps some of the younger members and people that are not familiar with some of the processes that are involved in the rail industry. But Meridian, my company, we've been involved, undertaken, delivered probably more new rolling stock contracts in recent years than any other private company in the UK. We class ourselves as facilitators, but what we've understood from the industry mapped our USP. So we specialised in homologation management and in turnkey end-to-end delivery of new stock. We've undertaken full homologation projects in less than 42 days for multiple iterations of the same stock. And anybody that's been involved in homologation projects, that's quite a record. So we've also moved trains internationally, and we were also the first company to move a train to mainland Europe post-Brexit. And we did that on the 4th of January. We're approved with HMRC and hold an account for customs guarantees, enabling us to complete paperwork necessary with the London Chamber of Commerce to transit goods outside of the UK. We're also the first non-EM to purchase test time off the Czech authorities. Excuse me while I turn the page. We've also developed our own vast amounts of test equipment, and we've worked with all of the UK and most of the European OEMs. And we've also partnered with some of the biggest names in the industry, and we hold global framework agreements with Dellner, who are synonymous for couplers, Deutsche Bahn, the German railway, and Deutsche Bahn System Technique, the laboratory, and some of the biggest OEMs around, such as Alstom. So, what are we going to cover today? Firstly, I thought I'd start with some definitions. Now, I know there are some very seasoned engineers here and people that have been involved in the rail industry that will probably understand this. But for those who are less familiar with the industry, I thought I'd cover some basic definitions because we tend to love them in the industry. And even though you may have a bachelor's degree, a master's degree, a PhD, and you may have seen enough abbreviations, symbols and formula to last a lifetime, when you join the rail industry, it tends to bombard you with phrases and terminology, which is not all that common. So today I just want to cover a few things. The first one is homologation, or as some people like to say, homologation. The next one is type testing, the phrase OEM, TSI, UIC, NOBO, DEBO, and ASBO. And ASBO doesn't mean that you have an antisocial behavioural order. But like I say, it is a bit different for people who haven't been involved in the industry. So the word homologation, which I'll be using a few times throughout this talk, it's really the term for the whole vehicle approval process. And it's synonymous with the approval that the government issue technically as a certificate that allows the product to enter into a market. Type testing and other activity, well, it's testing or other activities which determine whether a process, product, or service complies with requirements to a technical specification, standard, contract, or regulation. An OEM stands for original equipment manufacturer. And with respect to trains or rolling stock, it's a manufacturer that produces a product, obviously a train, that's often sold under another company's brand name. So in this case, it's often a manufacturer will produce something that's often sold to a Roscoe and then leased to a train operating company or a freight operating company to operate under a railway company's name. TSI and UIC. TSI is the technical standards for interoperability. So they are the European or Euronormal standards for homologation. And UIC, it's actually a French organization, which in English means International Union of Railways. But if my French is not that good, it stands for Union Internationale des Chemins de Fer. But it's the Union of International Railways in English. A NOBO is not a nobody, but a notified body. And they are an independent organization, usually appointed by an OEM, the manufacturer, to ensure that they have met all of the required European legislative requirements for the vehicle to be sold in the European market. A DEBO is a designated body, and they are much the same as a NOBO. However, they deal with the national notary technical rules, so the local jurisdiction rules. And the ASBO is an associated or assessment body which is concerned with the railway company safety case. And this is more prevalent when it comes to testing on the main line, and usually prevalent with the approval process or acceptance process, which we'll talk about a little bit later. So I've broken the main function of this down into stages, and the three main stages we're going to talk about this evening are the design and build, the test, and the approvals. So this is really the typical process for the road delivery, from conception to actually putting it on the railway and being used by passengers. So section 1 will be design and build, and this is the first stage of the OEM process. It involves creating a detailed plan for rolling stock. It includes everything, pretty much the layout, the dimensions of the train, the materials will be used, to specific features that will be included, such as seating arrangements, lighting, climate control, and so forth. The design and build process often involves consultation with the customer, the railway company, to ensure the train meets their specific needs. And we'll look briefly at the process, also opportunities and challenges that are faced in this. Section 2 will be the process of testing, and that involves building a prototype of a train, subjecting it to a range of tests to meet necessary safety and performance standards. The tests may include everything from braking to acceleration and running dynamics, essentially to test the train's stability and handling characteristics. And we'll also quickly consider some of the criteria and also the challenges in terms of infrastructure, tooling, and so forth, which I'll also talk to you about from our own experience. And the last section we'll talk about today is going to be the approvals. So train must be certified by the relevant authorities before it can be put into service. And this involves a thorough review of the design, the test results, and it has to meet all the safety and performance standards. And it's only once that all of those are met and satisfied that a train can be put into service and be used by the public, people like you and I. And I will summarize the talk at the end. So I guess we can now begin. So we have the design and build stage. So I have some notes here, which obviously you can pick to on the screen, and I will be following through with some slides, but I will give you a brief description of everything. The design stage is the first and most critical stage of the OEM process, and it's where the OEM works with the railway company to determine the specifications of the rolling stock, including layout, dimensions, features, materials. The design stage is the most important because it sets the entire foundation for the project. And any errors and oversights at this stage will have significant consequences down the line, especially in terms of time and money. During the design stage, the OEM often works closely with the railway company to ensure the design meets their specific needs and requirements. It sometimes involves several rounds of consultation and feedback to refine the design to meet the company's expectations. A useful reference at this stage may be the key train requirements document from the Rail Delivery Group, which can be found on the RSSB website. So, and we happen to be in that building today. Once the design is finalised, the OEM will begin a process of creating a detailed engineering drawing and specification, which will guide the construction of the rolling stock. These drawings and specifications will be reviewed by the railway company to ensure that they meet all the relevant safety performance standards, and any necessary changes can be made before moving forward to the next stage. Another important consideration is the need to design rolling stock that's compatible with existing infrastructure and operating environments. And this can involve ensuring that the rolling stock is compatible with different track gauges, signalling systems, or other infrastructure components, as well as ensuring that it can operate effectively in different climate and weather conditions. In addition to these technical considerations, an OEM must be aware of all the regulatory certification requirements, and they do differ around the world. So if you're manufacturing a train for France or Germany or the UK, things can change slightly. They're different in America, different in South America. And there are different safety and performance standards to consider, as well as differing approval processes and certification requirements. Ordinarily, the OEM will consult with the notified body to ensure that all the proposed approval strategy will meet the requirements of a TSI and a designated body, a DBO. So it's quite prevalent that there's a lot of consultation up front at the design stage, that things are checked so that it is feasible for these things to get approved once they go into service. But the OEMs need to be aware they also need to incorporate new and emerging technologies into designs. And rolling stock is becoming increasingly high-tech with advanced features such as sensors, data analytics, and predictive maintenance, which are becoming more common. So there are some challenges and there are some opportunities. Some of the challenges are in terms of balancing competing demands for designs. Factors such as performance, cost, safety, and environmental impact, amongst others. OEMs have got to consider these factors in their designs and find ways to balance them effectively to develop rolling stock that meets the needs of the railway companies and the regulatory authorities. But they also need to stay on top of changing technologies and regulatory requirements. Regulations do change and TSIs get updated, NNTRs, National Notary Technical Rules, get updated regularly. And we need to be aware of this, and it needs to be incorporated into any design. Once the design stage is complete, the OEM will begin a process of manufacturing, and typically involves use of advanced manufacturing techniques and materials. When we change materials and new materials are becoming available readily, new processes have to be invented, and we still need to manufacture things to the highest safety and performance standards. So it's a balance of costs, new technologies, regulatory requirements, research and development. These are all challenges, but out of these are also opportunities. And there are opportunities to leverage new technologies, to leverage new materials, and to develop stock that's more sustainable and environmentally friendly. And this can help an OEM. It can put them in a position as a market leader. Everybody's, wants to befriend somebody that's eco-friendly, and we should drive this in the transportation industry. An example of this is perhaps Hitachi's recent use of friction stir welding in the car body production. So things are changing, but there are some challenges and there are some opportunities there for the OEMs. The next section is my favorite part, and this is going to talk about the testing. So before rolling stock can be put into service, it must undergo a rigorous testing process to ensure it meets all of the safety and performance standards. And the testing stage typically involves several stages: a prototype test, a type test, and acceptance test. So with a prototype testing, it's usually a single unit of rolling stock, and we test that to ensure it meets design specifications to ensure it is safe and reliable. Now that testing may be done under a variety of conditions to stress test the unit. It will be tested at different speeds, different loads, and different environments. And it's often carried out in an isolated environment, such as a test track. Type testing, that usually involves multiple units, and rolling stock is tested in multiple form to ensure that it's consistent, that we didn't just test one unit that was good. It was a fluke that we put it together and everything worked. It's often tested more rigorously than prototype testing, and it's often carried out at a test facility again. Acceptance testing. This is the testing of the actual rolling stock in the real operating environment. So if we have trains for the south of England, tested in the south of England. If they're required for Scotland, they'll be tested in Scotland, and so forth. And it may involve running the vehicles on the tracks under various conditions, again at various speeds and various loads. Throughout the testing stage, the OEM often works closely with the railway company who witness the testing. And it's not uncommon for the NOBO to be on board as well. And this is to ensure any concerns are addressed before the rolling stock is put into service. It may even involve modifications, adjustments to ensure that all the specific requirements are met prior to delivery. Now, as I mentioned earlier, some of this testing often takes place at test facilities. And there are a number of different facilities in Europe, and we do have obviously one in the UK, which is Riddick, although GCRE in Wales is in the early stages of construction, I believe. So as you all know, the transport industry is constantly evolving, and with increased demand for better and faster modes of transport, there is a need for more advanced rolling stock. However, to ensure that new trains meet safety and efficiency criteria and are thoroughly tested, it's better to do it in a specialized facility. Now, as I mentioned, there are a number of different test facilities throughout Europe, but they all have different features and requirements. So what would you do to choose a facility that's effective for your project? Well, the test facility should supply different voltages. It should be able to test as many types of rolling stock as possible. It should be compliant for braking and traction, as well as current collection, and it should be TSI compatible. This is my wish list if I was to choose one or build one. It should be noise accredited. It should also have a higher track speed limit. And as ideally, you want to test at the unit's maximum speed. And new rolling stock is getting, it won't be long before we see regional trains north of 250 kilometres an hour. HS2 is on the cards here, and that has to be homologated to 80 kilometres an hour. So, a facility where you can safely test something that's isolated, away from the network, where if you have any issues, you're not going to put other signals to green or red, or if you've got some handling issues, you're not going to derail and upset and kill people. A facility is essential. But like I said, the number of facilities in Europe vary. One of the most well-known facilities is the one at Volym in the Czech Republic. It's about 50 kilometers outside Prague. And this currently is the fastest track to date. By 10% under certain conditions. But they have the best capability with That can be simple. Get up. Similarly, if a customer or another customer defaults on a test shift, failure to there's always an opportunity to change the shift time. Presented it. Take advantage of it. You need to have adequately prepared familiarization with the nature of the test required, have flexibility. A lot of these test jobs as I explained. Fun. Various components. Data can be used to evaluate the quite safe. But there's certain factors.
Yeah, I'm doing I'm on a webinar. Yeah, so
Equipment must be able
okay.
to capture data, like sampling rate, ensure all the relevant data is captured during testing. Certain braking tests, EMC tests, traction tests, high-powered electronics today, things happen a fraction of a second. We have to have very, very high sample rates to find out what's going on. Multi-channel data acquisition. Equipment should be able to capture data from multiple channels simultaneously. When it comes to braking systems, you can 50, 60 channels on some of the new braking systems. You need to know what's happening. Wheel speeds, slip, slide, brake pressures everywhere simultaneously. So everything has to be multi-channel. Accuracy and precision. The equipment must have a very high accuracy and precision to ensure the data is reliable for analysis. Spend a fortune getting stuff calibrated, but there's a reason for that. And compatibility. Some equipment needs to be compatible with specific components. We hold a lot of data acquisition equipment, but the main brain needs to be able to be compatible with additional sensors, accelerometers, transducers, other measuring devices. And the data storage and management. The equipment should be able to store and manage large amounts of data. I remember some of our test programs, after a week of testing, could have 10 gig of data. Now, our company has procured, collected, and owns a significant amount of data acquisition for sole use and for homologation. It tended to put us in a bit of a market-leading position in some way, with a huge investment. But often the OEM suppliers of a lot of this equipment have significant lead time. Some of the Duratron equipment for you, there are lead times of in excess of 1 year. So, you know, it's essential as well looked after, maintained, and calibrated. But having vast amounts of equipment does provide us with the flexibility of being engaged rapidly and execute most testing contracts without the need to procure secure or look to hire equipment. So one of the other things is transportation. Term referred to this for anybody who's not familiar, barrier vehicles. A barrier vehicle is essential during testing and homologation of new rolling stock. It literally provides the buffer between the train and a locomotive. It's used to move the test unit on and off the test track. It also provides means to propel a unit at speed when it can't under its own power. Now, anybody knows anything about pantograph testing, you have to tune its aerodynamics. Pantograph obviously can't be on the wire unless you have another similar unit that can couple to it and pull it. The only other way is using a locomotive with a barrier vehicle. Also, some traction and braking tests. The unit needs to undergo drag tests, and the safest way to do that is with a barrier vehicle. They're also the most efficient way of transporting vehicles to and from the test site. Our company developed, built, and we own 4 barrier vehicles. They're a little bit unique. They have height adjustable couplers with interchangeable heads. I think you can see this picture here. This is the mechanism here. Essentially, we are able to change the head and adjust the height within half an hour. And we have an arranged coupler head. So we have Delna 10, 12, we have tight lock. We have Delna 30. Pretty much you can pull up to any unit in the UK. You could adjust the height of the coupling and change the head very quickly. We also provided these vehicles with their own onboard generator. The reason for that, because we developed our own brake interface units. For the people at home that are not familiar with that, a brake interface unit is able to translate locomotive air brake pressure from the locomotive, convert these into electrical signals, which the MU like, and we're able to liven up the brake control wires on the dead hauled unit. Means effectively that the unit itself that's being towed brake itself under control of the locomotive. And that's why we call these universal barrier vehicles, due to the flexibility. Essentially, you can hook up to anything. It doesn't matter what height, within reason. It doesn't matter what head. And currently, our BIU is approved for use with all the Aventra series and electric start trains. And it can be modified very readily to work with pretty much anything. Okay. Vehicles are also capable of speeds up to 100 miles an hour. The gauge cleared from 99% gauge current network. So they are unique in the capability. But with transport, there actually are some real world problems, some proper problems that I would like to share with you. We've undertaken many moves of stock nationally and internationally, and done this through a variety of modes, both road and rail. Challenges with moving roller stock via rail come down to 2 things generally: permission and timetable. In the UK, you need something called an NRSC, which is a Network Rail Summary Compatibility. Basically. Similarly, in France, you need something much the same, and it's referred to as an ATE. You have to seek that from SNCF. Germany and Czech Republic, it's known as a BZA, but effectively it's the same thing. But often challenges are met when attempting to obtain an SOC or an ATE due to constraints in time. Often in the UK, it can be many months, perhaps even 6 months to obtain an SOC because of the process. And people are being very careful that you're putting something on a track that will actually go down there, won't take off platform or damage infrastructure. When we have issues with trying to obtain an SOC or an ATE in time, and there have been OEMs that want things tested within a matter of months, not 6 months, we've utilised road haulage to move the vehicle. And we've actually moved vehicles from UK OEM factories through the port of Immingham and onward to Cuxhaven in Germany. The reason why we can do that is because we move it by road very quickly. Move it to a port, put on a boat, and ends up on the German dockside. Once it gets there, we reform them on the dockside. We're able to obtain BZAs very quickly. So we can reform and use barrier wagons to transfer them onward to the Czech Republic. So with respect to moving trains from the UK to the Czech Republic, we chose Cuxhaven Port, Germany, as it was the most favourable destination for ease of onward transport to the Czech Republic. It provided some means to reform the unit on the dockyard. However, Cuxhaven Port does face the North Sea. And given often I was getting contracts that were required to move trains in the middle of winter with temperatures that were probably sub-zero and winds that were hurricane strength, the team I had were not initially overly thrilled about having to work on the dockyard in such conditions. But we had an in-house entertainment officer who explained to the rest of the team that Cuxhaven was actually the #1 party destination for Germany. So the enthusiasm sort of grew. Of course, that wasn't literally true, but fortunately the team took it with good spirits and made the best of the situation. Some of the major challenges that we faced later were due to Brexit, COVID. In March 2020, we were several weeks away from completing the homologation on the Class 701 fleet. We also had an SNCB project at Willem at the time. On the 12th of March, we saw the Czech Republic close its borders. It was the first in Europe to do so. It was a Thursday, approaching the weekend, and it was a scheduled shift change, meaning that 3 of my team had left that morning. This was all done at a moment's notice. Boys got on the plane at 8 o'clock in the morning. By 10 o'clock, we were told that the borders were closed. So literally, myself and one engineer were left, and we're unable to return to the UK for 14 weeks. I couldn't get anybody in, but we were determined to finish the contract. And logistically, it made it quite interesting. The 701 unit was programmed to leave Willem on the 23rd of March, so it was 11 days after they closed the border. However, we made some checks, made some calls, Germany, Czech authorities, and it was possible to move barrier vehicles from Germany into the Czech Republic. Couldn't get any staff in, but we could get vehicles in. The drivers for those locos bringing the vehicles in had to be swapped on the border. No other support staff in the country. So myself and my only remaining engineer received the barrier wagons with brake force wagons, and we formed up the rate, provided a fitness to run, waved it off to Germany. But fortunately, around that time, German authorities hadn't introduced such strict entry for UK people. And so what I did is we sent a team in to Germany a week before the train was due, and they were able to split the train on Cuxhaven dock, load it onto low loaded, and it was received back in Derby. And the following month saw us, in fact, our entire team, seek and obtain Czech residency, primarily due to the government rules that COVID going on, Czech citizens and residents could enter the country under COVID-19 restrictions. So we figured that was essential with the ongoing contract we had. But also, we didn't know at the time, it would also benefit us to live and work in the EU without the need for visas, and that later became apparent. It's important as of 2020, until the end, 2021, until the end of free movement. Business, energy, and industrial strategy. Nice people. We liaise with them quite regularly. They provided us with letters of exemption due to the nature of our work, moving, testing, and repatriating trains. And of course, the need for our staff to see their families every few weeks. We're probably some of the most well-travelled and bureaucratically experienced individuals throughout the pandemic period. We all got very familiar with the different COVID rules and many differing country. But it did come at some cost, both to the company and to the individual. Even going to work at the test track, 50 kilometres away from where we were staying in Prague, we needed special forms to leave the hotel. We needed to make statutory declarations upon entry to the test facility every day. We needed to undergo COVID-19 tests every 72 hours. And should we wish to repatriate home, we would require paperwork to transit through the Czech Republic. The same for Germany, Belgium, Netherlands, France, and the UK, all with valid COVID tests. So we walk around with telephone books each. And the paperwork validation would vary from country to country, meaning some areas the paperwork was only valid for 48 hours. And others maybe 72, but the end result was once you return to the UK, you have to start the entire paperwork exercise again to return back to the Czech Republic perhaps 1 week later. And as a small company, it was costing us obviously significant money in terms of tests. The 4th of January 21, we needed to move a Class 730 unit from Derby to Berlin. We started the process in October of 2020, knowing, well, not knowing, should we say, what, if any, Brexit agreement would be struck. And as we know, on the 24th of December, our Prime Minister at the time, Boris Johnson, did agree a deal. But this was a Christmas period and only 10 days prior to us contractually needing to move a vehicle. And we did move it. We were actually the first to move a unit post-Brexit. We used an ATA carnet, and this was the largest and heaviest item to be moved using at the time. As a result of our successful move, the government later issued this as standard procedure. Now we're members of London Chamber of Commerce, and we hold customs guarantees with HMRC to enable prompt completion. The need for spares and the freshly introduced bureaucracy meant courier services were subject to checks and processes that they were also not familiar. Potential delays in receipt of parts and adverse risks and cost of the program, our resolution was to sort out the paperwork and drive the parts through ourselves, which we did. And anybody that's been involved in testing, things do go wrong. You need spare parts. Sometimes you need to be the jack of all trades and ensure the success of the program. And it did, for us, demonstrate the challenges in respect of dealing with freshly presented Brexit. But homework paid off. So that was some of the interesting stuff that we dealt with at the time. The last stage I'm just going to run through is the approval. And so as I mentioned in the first segment, once a design is tested, run through testing stages and process with the OEM, the train must be certified by relevant authorities before it can be put in service. The OEM plays a key role in this process together with a Novo Devo. So we're familiar with what a Novo does there. I have a slide for you. Now they really deal with the technical specification for interoperability standard, but they'll also deal with the common safety risk evaluation assessment. Devo, just so everybody's refreshed again, much the same, but they deal with mainly the national notary technical rules. So the OEM works closely with these authorities during the approval process to ensure the train meets all the necessary performance and safety standards. The collaboration can involve providing documentation, test results, other information to demonstrate compliance with standards. Before the stock can be put in service, it must go through the rigorous approval process to ensure that it meets all of these things. And that typically involves the regulatory bodies, both nationally and internationally. One of the most important bodies involved in the design and build is the International Union of Railway, UIC. And they are prevalent and responsible for developing and promoting international standards for rolling stock, including safety standards, interoperability requirements, and technical specifications. But in addition to them, there are a number of national and regulatory bodies, including the RSSB, that oversee some of these regulations and for overseeing the design and approval process. These bodies often have their own specific requirements to standards, which must be met in order for them to be approved on the network. But the DBO plays a role in managing a lot of that. The homologation process typically involves a series of tests that are conducted by the railway company or the relevant regulatory body. These tests may include the rolling stock compatibility with the signal system, the track gauge, and other infrastructure components. And it's once the rolling stock has passed all of those that it can be approved, sign off. The approval process is quite complex and lengthy. It typically involves a range of stakeholders, including regulatory authorities, railway companies, and OEMs. The process can vary depending on region and specific regulations and requirements. Generally, the rolling stock is involved in a series of tests and evaluations that are designed to ensure it meets specific safety and performance standards. And these are generally dynamic, brake, electromagnetic compatibility, amongst others. The overall approval process is important. It's important for ensuring the safety. It's important from our own point of view, in terms of us using the railway as customers. And the OEMs play a pinnacle role in this, in the design of it, meeting the regulatory requirements, and providing the necessary documentation to facilitate the process. And just to summarise my presentation, the concept of an OEM is a critical one. Design, build, and approval process. It allows railway companies to get on with their business of operating trains. It leaves the design and build process to experts. It ensures that rolling stock is built to the highest possible standard, meets all of the necessary safety and performance requirements. We hopefully see some benefits from that, like reduced cost, improved quality, customization. If you want nice flashy lights or seating in a different way, then speak to an OEM. Access to the latest technology. You know, there are emerging technologies. OEMs are generally familiar with those, and also compliant. To conclude my summary, we've discussed how OEMs play a critical role in rolling stock market by designing and building rolling stock. We've explored the importance of the approval process in line with regulatory requirements for safety and performance. I've highlighted some challenges and opportunities that OEMs and facilitators, even people like me, face in this market. These challenges include balancing competing demand, design, staying on top of changing technologies and regulations as well. Logistics can be a problem. Test execution can be a problem. It can also be opportunity. There are opportunities to develop innovative and sustainable designs and to come up with some smart ways of working. But ultimately, the success of OEMs in the rolling stock market will depend on their ability to adapt and evolve to meet changing needs in the industry. It requires a commitment for ongoing research and development, a willingness to take risks and innovate, a focus on delivering high quality, reliable rolling stock that meets the needs of customers and regulatory authorities alike. But in conclusion, the concept of an OEM manufacturing rolling stock design and build and approval is a critical aspect for the railway. By understanding their role, their challenges, their opportunities, then perhaps we can work towards building a more safer and sustainable railway and a more efficient system for the future. Any one person or company involved needs to appreciate the complexity, rise to the challenge. If you have any questions, please let me know, and thank you. Thank you for listening.
Okay, thank you very much, Andy. Fantastic presentation, really insightful. Thank you very much for sharing your experience and your knowledge with us tonight. Has anyone got any questions for Andy? Chris?
So it sounds like you must have become an absolute master of bureaucracy in what to me must have been a huge number of hurdles to jump through. What advice would you have for the industry, maybe in this country, in terms of either finding ways through it more efficiently or
It's a good question, Chris, and thank you for that. And I think that is probably what we have almost developed in a way, primarily because we had to. You know, we were contracted by Bombardier on a number of contracts prior to Brexit, and we knew that they were due to be executed post-Brexit, but nobody knew at the time what Brexit looked like, and I guess it's still not completely clear. But fortunately, I'm supported by Fiona, Rosemary, the client, company manager, and we've got a lot of help from the London Chamber of Commerce. With Brexit, there is a lot of bureaucracy, and whether we want to face up to that or not, we do have to abide by customs regulation and so forth. Now, we are also bound by our own regulations in terms of Network Rail and issuing SOCs. If we move a train by rail, it's usually 50% of the cost of moving it by road. So the preference is always try and move it by rail. And obviously, if a unit has been validated or tested, the factory and it's formed up, you don't really want to have to split the unit up because it adds extra complexity, it adds extra risk, extra time for retesting and validating. So my view would be this, and my advice would be this to anybody: if they need to move a train and they know that they're going to build a train, because generally if you get an order from a customer, you know you're going to build one at some point, I would file for an NRSC statement of compatibility as soon as possible. The moment you have your design pretty much fermented, and start making the paperwork now. I mean, generally an SOC will last for a year and it can be renewed. Once you've got one, to renew one or to add to it, to amend to it, only takes a week or 2 weeks. To get one initially can take 6 months. So the sooner you file for an SOC, the sooner you can move a train. Obviously, you need to know where you want to move it to, because you need to look at specific areas. So Network Rail can check the gauging and so forth. But that's going to help. If you need to move it cross-border into France or to Germany, again, it can be difficult. With Germany, it's a lot easier. Get a BZA, they have a different system to assess things, and generally most German trains have to be a lot bigger than English trains. So it sounds crazy, but we couldn't get a statement of compatibility through Network Rail for a British train in England for 6 months. But I could get a BZA for the same train to run through Germany in 48 hours. And ATE and France can also take several months, depends on the backlog. And they previously did have some issue, not with GO trains, but with French trains taking off platform. So they're very, very careful. There are standards to apply to. Paperwork is not that difficult, but it's all about time. But in terms now of moving the trains cross-border, it's not just getting permission, but you need to get the relevant carnets in place. Now, when we first applied for a carnet, and the reason why we went down that road, we had senior policy advisors talking to us, asking us how we did it, because obviously we were the first ones to move it. We looked at the fact that we were becoming a third country. We looked at the fact that there was a number of countries we needed to move them through, and they all have different regulations. The ATA carnet basically provided the train with the same passport, and it was the simplest, surefire way of moving the vehicle, because pre-Brexit, pre the agreement, we didn't know. So we looked at every possible scenario and said, well, that's our bet. But when we wanted to move the first train, we're a bit naive. We're not so naive now. We applied for an ATA carnet, and it was not a problem. Would you like the completely refundable option, or would you like the pay a deposit, never get it back scenario? Oh, the completely refundable option sounds great. Well, that's fantastic, sir. You'll get your money back 38 months after your train returns to the UK. That doesn't sound too bad. And what's the cost of that? Well, what's the value of the train? About 10 million. Okay, well, if you give us 10 million, we'll give it back to you in 38 months. What's the other option? It's still not cheap. You know, I think that the first carnet that we took out was in the tens of thousands, like 30, 40,000 pounds for a train that we only need to move for a period of 3 months. And I think we got a deal on that because nobody had done it before, and HMRC and London Chamber of Commerce, you know, helped us out. But it is expensive. You know, we move tooling quite regularly. I mean, we do jobs in Germany occasionally, in France, and we used to be very reactive. We've had calls from CEF1 in France in an afternoon. Could you bring some weighing equipment over and weigh a train for it? No problem. Throw it in the van. We'd be there in 3 hours. Now, it takes a couple of days. You know, we have to apply to get an ATA carnet. We have to get this signed off at Folkestone. We have to get it signed off in Calais. That takes time. It takes time to raise the paperwork, and it also costs money. For us to take a van load of equipment, even for one day, costs us £1,000, £1,200. They're all considerations, and unfortunately, you know, we are in a situation post Brexit that we're going to have to live with. There are opportunities for it. One of the opportunities that we found is that we became experts in moving goods, and perhaps we can charge for some of that knowledge. And there are restrictions for it as well. You know, it can make you less flexible, and less reactive. It can also add premiums onto a job, and if you can't be there tomorrow, and it's going to cost another £1,200, well, actually, maybe somebody from Germany can do it the day after and be a bit more competitive. This is the reality. But when it comes to likes of new rolling stock, you know, we are limited currently in the UK where we can test it. Yes, we have really, and it serves a purpose, but it's not ideal. Okay, GCRE, you know, I commend them for what they're trying to do, but they're in the early stages, you know, and I don't know whether it's going to fully meet everything we need going forward if we were to produce new rolling stock at high speed. Ideal for perhaps some of the new emerging technology, ideal for storage, ideal for some of the network rail testing and so forth. But if we produce something like HS2, the reality is it will probably have to go to a European test centre, and there will be challenges getting it there. But we've been there, met them, dealt with them. We're a small company, you know, we're happy to talk to people. So yeah, any issues in that regard, come talk to us.
I had a question. Well, actually, no, it's two. First part is, do you ever have to develop your own tests for during the type testing, or can you manage to always find a
do that? So if an OEM will always liaise with Novo and a Devo. Often we get specifications directly from the OEM. But if, for example, there was an amendment to the test or a test that they hadn't been able to script, provided we know what the anomaly is, like that. I mean, we've even developed certain test equipment ourselves to accommodate some of this. One of the things that we had to develop ourselves was speed acquisition equipment, because when you're testing and homologating a train, you can't rely upon the train's own speedo. You have to have independent reference. So we developed our own speed acquisition equipment for this, where we have screens in both cabs and in central car where we would perhaps hold a test bench. We've even developed our own communication system for those sorts of things. And in fact, we even work very closely with Moore Schmidt, and we actually developed and we own the only portable dynamic AWS TPWS kit in the world. Because at Berlin, There is no AWS TPWS system obviously used in the UK, but our system that we developed is portable. We can deploy it in any track, anywhere in Europe, in the UK. Includes mini grids. Like it's more comprehensive than what's already. It's deployable in 20 minutes. So we've had to develop test equipment, and we've also developed some test methodology for that as well.
I'll have a second question. I'll see if there's.
Yeah. So, in fact, in some ways they do. They always produce generally one or two trains. The first one or two trains are generally referred to as test trains. In some cases, they're not fully fitted out with all the seating, all the panels, and so forth. Often, testing. If you've got a new train nicely fitted out with carpet and panels and everything, and we're walking up and down it for 3 months with test equipment, and spanners and screwdrivers, obviously you're going to damage some of the interior. So often the trains are not complete, but they're representative of what they would look like. And in fact, if there are panel seating missing, you need to take that into account for testing to accommodate for that by putting ballast on, additional weight, and so it is a proper representation. But often those trains then go back after we finish with them to be refitted, and then they're sold to the customer. And I think the reason why they don't just have a train that they use as a prototype and scrap, it's quite expensive to make a train. Yeah. But we're, in some cases we're talking, 10 million or more, and it takes time. So you're making best use of a test train because it will be utilised for testing. You will try and iron out all the faults, and then once we're finished with it, any upgrades, because often train 1, train 2, we might find things that are wrong with it. They may even be negligible things, but for maintainability. But there will be upgrades to maybe some hardware, some software, and so forth. And 3rd, 4th, and 5th trains, as they're going through the build process, will be automatically upgraded. The first 2 test trains have to go back to be rebuilt and be upgraded as well. If you're making millions,
100,000 plus, right, that cost over for a particular type of train, even though 720 might look like a 710, actually you're writing it off over a couple of 100 vehicles because the next build looks the same, but actually technically it's quite different. So you have to write the investment off over a much short period of time. It's sort of my feeling. I mean, you may have that may sound talking rubbish there, or you may want to expand on that, but that was another thought that occurs to me.
Thank you for that. Any questions online, Chris? No. Any more from the room? Yeah. Let me.
Thank you. It's more of an observation, really, and my own experiences, which is I think what you've developed is really good creative problem solving, and you've developed a resilience to like, okay, we'll do that, because no matter you do one previous train project and you get a new one, and it will be different. Only 2 things have to change, and it's radically different. And you could have one process where you go to deliver the train, you think you've got everything okay, someone turns up and said, can't do that. And it's like, well, when were you going to tell me that? We've got 1 hour. Do you think that's a fair observation?
I think so. I mean, for us, we've always prided ourselves in offering value for money service, and you know, some people say that we're not cheap, and we're not, but it's not necessarily the cost of what it's worth. We turn up, we take on a job, say we're going to do it. We've always done it, and we've always delivered actually early than budget, and we often do things for profit as well. Where I have to take on some risk. But with the barrier vehicles, yes, what we've got to do is produce a new preferred solution where, you know, even if we turn up to something that actually it's not quite what the customer described, very quickly, you know, we can adapt, we can change the coupling, change the height of it, and away we go. With the test program, I had to develop ways to manage the homologation management, because it's costing me if we lost a test ship. And it wasn't just losing money, but it was losing the ability to then perhaps complete it on time, because the test ships are few and far between. And we were buying test time back in 2018 up in 2020. We were buying it 4 years in advance. And it is challenging. So we have to plan to keep to a plan. You've got to have an end goal, but you have to have that flexibility. So we would instrument for everything. We'd have all the guys familiar with all the specifications for everything. And yes, we'd have a plan that we're going to do some acoustic testing today, we're going to do some braking testing today, or some traction testing. But we'd have 2 or 3 backup plans just in case if we had a system failure, if one of the guys got sick, one of the leading got sick, or if there was issues with weather and so forth, then we could go to plan B, plan C. But the main plan was to progress the entire plan week by week. So we have to monitor things very, very carefully. And it's just being resilient and resolving a problem. Everything is a minor challenge. That's all. It's never a failure, and it can't be. You know, a lot of people depend upon it. For us, even during the COVID time, you know, we could have probably called force majeure and said, "Look, God, we're out of here." But you know, it was important for us. We wanted to complete the contract for the people, not just for the company. The effect on our income, but apart from that, you know, the end users, the customers, Southwest Trains or Slow Train people, West Midlands, they were all dependent on things happening on a certain day. And for the end user to be able, the customer, the British customer, to sit on those trains, if we'd walked out, it could have been another 6 months, a year, 2 years. So, you know, yeah, sometimes you have to. And that's what I said in the feature, that people are willing to take some risk and they're willing to adapt to it, and there's a willingness to deal with it. If you can get all the right people, and there is a lot of people, it's a very complex operation, very complex process from design to delivery, but we have got some good people in the country. Get the right people in the room. Actually, I think you can do anything.
Thank you very much. Well, I think
Your voice rest.
but again, thank you very much for coming to give us today.
Thank you for inviting me. Yeah.
It's been a really good talk. I hope you've all enjoyed it. I think we should show our appreciation one more time.